Good afternoon, everybody. Hope you had a good lunch and are ready for some more information, good stuff. Now I would like to introduce David Chandler from Sencha, I think it's called, or?
Yes.
Yes, great. And he will show us about how building amazing HTML5 apps with Sencha GXT. Please give him a big hand.
Thank you. Good to be back here in Stockholm in the winter. I love Stockholm in winter, especially when there's snow. It's much prettier than the rain I understand you had last week. And sometime I want to visit in the summer too. I think the archipelago and the sea would be nicer, but it's a very beautiful town. So we're here to talk about GXT today. Some of you may recognize me. I used to work for Google and represent Google Web Toolkit. So I just have to ask at the outset, how many people are using GWT today? Okay, surprisingly few actually for this audience. So this product is based on GWT. So I'll tell you just a little bit what's going on in the GWT world first. GXT is a Java library for building rich applications with GWT. Speaking of GWT, I just came from the GWT.create conference in Munich. We had 670 attendees this year between the US and the EU, which was a few more than last year. The GWT community is very excited to see that GWT is not dead, because there were a lot of people saying that it was, and 670 people demonstrate otherwise right now. When I left Google about 2 years ago, we were all sort of holding our breath to see what would happen. Google did a very nice thing, and they fully open sourced GWT, made it part of a steering committee that now has representatives from Vaden, from Sencha, from ArcBees, and there's a couple other independent developers as well. And the community has actually taken the ball and run with it. But that's not all. Google Inbox, the flagship email application, the brand new one from Google, it turns out, is also written in GWT. So those people who were saying that GWT is dead even within Google are in fact very wrong. Google still has no alternative for building complex rich client web applications. Even though Google is producing frameworks like Angular right now, it still turns out that for large products that perform well, that the GWT compiler is still the best option. There was a very interesting talk at GWT.create, which will be online for free, I believe, here in another week or so, by Ray Cromwell on the GWT team, in which he showed how they actually compile, cross-compile the GWT application to the web, to Android, and even to iOS using the J2 Objective-C compiler. That's an open source project of Google as well. So they're able to reuse 70% of the code across their the Inbox application by writing in the GWT compiler. The new Google Sheets application is also written in GWT. And I can tell you from a company perspective that some of our customers use our grid widget to implement spreadsheets as well. And it would really be hard to imagine implementing something as difficult or complex as a financial modeling engine in JavaScript. You really want the benefits of a strongly typed language, JUnit testing, and all the infrastructure that goes around Java for doing that kind of a thing in the browser. At the present time, GWT has about 100,000 developers worldwide. The dev server makes pings home so that we can actually measure this. So it's never going to be the latest, coolest framework again, like it once was. But it still fills a valuable niche in the enterprise marketplace. If you want to develop rich client applications and you are primarily a Java shop, then the GWT compiler remains attractive. We also find that a lot of enterprise applications, which tend to be grid-based or have advanced reporting or charting features, prefer to use GWT with our widgets. Because they just suit enterprise applications well. So a lot of our customers told us at GWT.create that they really couldn't imagine writing their application without GWT because of the power that it brings and manageability. So if we don't have many GWT developers in the room, so you may not be aware of the dev mode fiasco, but the selling point of GWT for a long time was what we call now classic dev mode, which allowed you to step through your code in Eclipse or IntelliJ in Java that was actually executing in the browser. And this was a great little miracle that used a browser plugin. So what would happen at the time was that you would actually use the JVM in Eclipse or your editor to step through your code just like normal in a Java application. But there was a little code server built into the plugin for Eclipse that would communicate with a browser plugin and would actually send changes to the DOM back and forth that were the result of your Java code changes. So with classic dev mode, you were actually able to debug a web application using your favorite Java IDE, which was a great, fantastic feature. It was always a bit slow to start, slow to refresh, but the power was helpful and was one of the reasons people said they couldn't see it doing it any other way. Unfortunately, this relied heavily on browser plugin APIs, and every browser has their own plugin API. And over the last couple of years, the browsers have all retired those APIs, with the exception of Internet Explorer on Windows. So right now, if you want to use classic dev mode, you are stuck with some ancient version of Firefox, I believe it's 26, or Internet Explorer on Windows. And sadly, even Chrome has deprecated the NP API that the Google plugin was using for GWT. So the GWT team said, what are we going to do? They didn't want to spend the effort to continually maintain these old outdated browser APIs, and so they came up with super dev mode, which is what most people thought that the original dev mode was doing, but it wasn't. What super dev mode does is actually does incremental compilation now of your Java code and produces JavaScript on the fly, and then creates a source map that is readable by Chrome especially. Works in other browsers as well, I believe, but it works best in Chrome right now. And with that source map, what you can actually view in developer tools in Chrome, your Java code. I'll do, with any luck, a demo of that shortly. So super dev mode now has replaced classic dev mode, and the big challenge over the last year has been getting it fast enough to actually be usable for developers. So let me just start with a little super dev mode demo to show you where things are at currently developing a GWT application. So we have this application called eDash, or Executive Dashboard, that we've written using the Sencha GXT library, and to show off some of the features, and I'll be talking a little bit more about that later. But you can see right now this is running on localhost port 8888. It is running in GWT super dev mode that I launched from IntelliJ. And currently, we notice there's an item over here that says profit and loss. So I just want to change the text and make it say profit and profit, because we're thinking positively today. I'll switch back and hit refresh. It's actually doing the incremental recompilation right now, and voila, there's our new application that says profit and profit. So this is a much, much faster refresh cycle than used to be possible even with classic dev mode. The problem with classic dev mode was that as your application got larger, it would get slower and slower and slower. And so it was, there was one large application in Google, for example, that would take like 30 seconds to refresh, which is an unacceptably long developer lifecycle. That's almost enough time to learn the latest new JavaScript framework. So we have now much better performance, and because the super dev mode compiler uses incremental compilation, as your project grows, the dev mode performance does not get much worse. So this 3 or 4 seconds that you saw here is typical for a good sized project. And I have been told now that the largest project inside Google, which uses GWT, will do a refresh in 7 seconds, which is so much faster than the old one that they're really pretty happy with it. Granted, it's still not your sub-second refresh if you were writing in native JavaScript. But if you're writing an enterprise web application and it starts to get big, That's the trade-off, right? You'll find that the manageability of being able to write in Java is worth it. So let me, I mentioned the GWT steering committee. Yeah, let me just ask at this point whether anybody has any questions about GWT or Google Web Toolkit, as it used to be known generally, before I go on. Because it won't make sense to build on that if you're all dying to know something about it. And I just came from the GWT.create conference in Munich, so my pump is primed and I'm ready to tell you all about it. Questions now, anybody? Oh, lunch was too soon ago, wasn't it? Okay. Well, I'll just truck on then. If at any time you get the burning desire to ask a question, please do so. We don't have to wait till the end. Okay, so Sencha GXT is built on top of GWT, and it's a native GWT solution that uses no external JavaScript or third-party libraries. And this is important because it's an unusual approach in the GWT ecosystem. But part of the promise of GWT and part of why people use it is because of the optimizing compiler, and specifically for dead code elimination. So when you pull in, if you're writing a JavaScript app and you pull in your various libraries, they're starting to get more modularized now, so it's better than it used to be. But basically you're taking the performance penalty of sucking in the whole library that you're depending on, like it's Dojo or whatever module of Dojo you're using. So what the GWT compiler actually does is, as it walks through the tree of your Java code, it will actually eliminate any code that's not actually used. So you can pull in a library with 1,000 Java classes, but if you're only actually using 5 of them, only those 5 will get compiled to JavaScript. So it produces the smallest application that you can have, and still lets you benefit from the wide variety of applications that are out there in Java, third-party libraries, etc. So GXT is written purely in Java. Now Sencha has another product, the Ext.js, EXTJS, see it written, which is a JavaScript widget library. And a lot of people think that our GWT product just wraps that. And indeed, like 5 years ago, that was what we did. But starting with version 2, I believe, it's about 4 years ago, the company rewrote it completely. The GXT library is completely in Java. Which means if you want to, you can step through the source code of our widgets in the debugger and now super dev mode. You get all the benefits of the dead code elimination, and the optimizing compiler fully applies to our widgets as well. So in your resulting JavaScript artifact, you're only paying for what you actually use of the GXT library. It's designed to be high performance and highly customizable. So we're using the new flyweight pattern. I'll talk about that in a little bit later. It's designed to have a reasonably well-designed and consistent API. There's still a bit of a learning curve, but it is consistent, more or less, with well-documented source. And I'd just like to point out we've been making a lot of improvements recently in this area as well. So if we switch back to the browser for a moment, we've been building out the documentation and explaining basic concepts, creating developer guides for a lot of the common Sencha framework elements to make it easier to get started. We've also created new Maven archetypes, which make it really easy to get started. Let me just demo one of those really quick. Actually, let me clear up the last demo because I think it's still on my system. Always gives me a little bit of panic when I type rm-rf, as it should. Yeah, I think we're clean. It may have already generated the IntelliJ project, but that's okay. So there's 3 archetypes that are available right now, and they're published. How many people use Maven? Yeah, lots. Okay. That's what I expect in Europe. In America, it's a little bit less. And now there's so many new build systems. Okay, so if we just copy the Maven archetype command here right off our website in the documents, you can paste that onto the command line and answer the 4 questions. We will call this demo and com.example. Yeah, why not? And okay, it creates the package. You can see all the files. Actually, let me cd into the demo directory and do that again. All the files that are generated here. I believe I already have the project open in an IDE, but you can, at this point, import it into IntelliJ directly. Let me just flip through my projects and see if I've got it up. I don't think so. Yeah, okay, we'll re-import it then. That's fine. Okay, so you see that the generated pom.xml specifies the 3.1.1 version, which is next to the latest of GXT, is using GWT 2.6.1. And we could be using 3.1.2 and 2.7 now as well, which would give an even faster dev mode experience. And the main thing you need to use Sencha is just to put the inherit in your gwt.xml to inherit the Sencha packages. There's also a theme called the Neptune theme that we're bringing in, and there's others that we can bring in, other Sencha modules like charts, which we'll get to all that. But this is a basic project, just has a hello button.
Sorry?
Yes?
Is that a mandatory file? Like, you always need that one?
The gwt.xml?
Yeah.
Yes, that's part of GWT. Every GWT project has the gwt.xml. It's like the web.xml of your client-side application.
So without that file, you can't do anything?
No, that's your starting point for GWT. All right, so.
And it also needs to be named like that, with.xml.
Yes. Yeah, it's just, yeah, it's really analogous to your web.xml for a server-side app. So Sencha GXT is actually data agnostic. You can access data any way that you want from your application. But we provide basic wrappers that allow you to quickly interface your RPC services if you're using GWT RPC. Request factory or just a plain JSON REST API. And you can also do a custom one, which I should be able to show if we have enough time later as well. We have full theming support, which I'll talk about in a little bit. And then our business model is, it's split. We have an open source version, which is GPL'd. And if there is a provision in there that if your project is open source under various open source licenses, then you can use the GXT project for free. If your project is commercial, that you're charging for it, then you need to pay for a developer seat or seats of GXT in order to be able to use it. But it's a royalty-free license. It's just based per developer. So let's have a look at some of the widgets that are available. This is really what made GXT popular with our customers early on. We have an Explorer demo available online at the website, which will let you see all of the widgets in action. So this one is actually one of our widgets over here on the left side. It's called a filter tree, and I can just put in a little bit of text and filter out those items in the tree, which is powerful. The charts tend to be very popular. We'll talk about those in just a little bit and show some of those. And then the grids are also kind of the workhorse components of a lot of enterprise applications. So a filter grid is particularly useful. For example, I can come up here, edit the filter, remove it. I can sort quickly. You can define your own comparators for sorts. I can put in some different filter text here. So that's, I'm not going to show all of the widgets here, but that's where you can find them at the Explorer demo on the website. and see what's available and whether it fits your application. Charts, we have about 20-some chart types. Bar charts, area charts, pie charts, gauges, all those kinds of things. They're all nice looking charts. They do not use any third-party library. They're fully written in Java to work with GWT natively. So if you're looking for a good charting API and don't have time to write your own charts, the developer license may be just the ticket for you. I did my getting started demo too early with Maven. Okay, so now I'll talk about a few GXT features in 4 groups here. We talk about the cells and widgets, and then layouts and UiBinder, stores and loaders, and charts. But before I do that, let me come back to this demo of an amazing HTML5 app written with Sencha GXT and show you a little bit more about it. So GWT has a concept called activities and places that allows you to work with the browser history management. So you'll notice as I click on these various headings that they are showing up in the URL as well. And what's actually happening is that in GWT code, a new activity is being loaded for each one. What that activity is actually doing, actually it's not a new activity. The KPI, the first part of the URL, is the activity, and this is just a parameter that's appended to the URL. What's actually happening when I click on these different things is there's only one data set for this application, but that data is being filtered in something we call a store. So you put the data in the store, and then you set a filter on the store, and then the store automatically updates the widget associated so that the chart data changes. So this is one of our standard area charts. This is a standard pie chart over here, but with the donut flag set so that you just lose the middle of the pie. This is a tiny custom widget we wrote for this demo that just does CSS width to set the width of the bar. If we look at the next view, the performance view, this is a candlestick chart, which we haven't put into the framework yet, but it was not too much work to extend the bar chart to also show the candlestick. And that's something that we're looking at adding to the framework. This is a standard menu button up here. So if you click on it, you get a button action. If you click to the right, you get a drop down. And so this is exactly the same as the menu button that's part of the framework. If I click on the menu button options down here, you can see the same kind of behavior. I can click on the button or I can drop down to the right. Same widget, just different styling. You'll notice that this is also a responsive view page. So let me shrink the browser window a little bit here. Okay, and when I adjust the width, you'll notice that the columns are adjusting, the chart is adjusting automatically. This is all just standard CSS layout. But then once I push it past a certain width, we're only going to see one column instead of 2. And then when I push it a little bit further, you're going to see the menu bar move from the left side up to the top. And that's actually being done using a window resize handler. Once it goes below a certain width, we're just catching that and then switching to a different border layout where it's on top instead of on the left. You could also write it with pure responsive design CSS techniques, but honestly it's easier in this case just to programmatically detect that and change the whole border layout. We look at over here on the profit and profit page. This is a split grid. This isn't part of the framework yet itself. We actually simulated it, but it's very easy to simulate. So this is actually 2 different grids. We have a grouping grid on the left, which controls the expansion of the sections. And then on the right, you notice when we scroll right, the left column is unaffected. So it's a locked or split grid kind of capability. We can adjust the column widths. That's a standard feature of the grid widget. And we can select the data that's in here just by using that drop-down menu, and it will immediately update the grid. So I just want to point out that this split grid capability, in order to make it scroll together, we just basically ferried the event handlers. So we implement the on-scroll event handler on the left side and then just send that event to the right and vice versa. So the two grids are communicating, and that's why they appear to be one, even though it's actually a simulation. But we're looking at adding the split grid as an official component to the framework now that we've already built it. And lastly, this is just a list view, which is a component which acts very similar to a list view in Android, except you can style them lots of different ways. So this one uses something called an XTemplate, which I'll talk about. Just do a basic CSS, expand and collapse. It's the same component as this list view, which has a much different appearance, just because it's using a different template to control the layout of the list view. And then we have a filter operation taking place here with the drop-down menu as well. This application was built in about a week by one of our guys who's pretty good with design and styling, and I would say the majority of effort in it actually is the CSS work, because the widgets are pretty straightforward. You just drop them in and use them. Okay, so let's go back and talk about some specific features now, starting with cells and widgets. So you can see them in the Explorer demo. You know that they're customizable because we've seen that now. GWT introduced the appearance pattern in the core framework, and we tracked with that, so we also allow the appearance pattern. So this is where you're actually writing Java code to customize the behavior of the widget a little bit beyond what you could do with just CSS. You can still use CSS, of course, as much as you like, but if you need to customize a little more deeply, then that is supported. Our widgets work with the GWT editor framework, which allows data binding to and from components. And they support asynchronous retrieval of data, of course. There's also auto state management available. So for example, the grouping grid, which groups are selected can be automatically persisted via the mechanism that you choose, local storage or cookies or even an async call to the server. It's not on by default, however, but you can choose that when you instantiate the widget. All of our widgets, all of our cell widgets specifically, are designed to be interchangeable with the GWT cell widgets. So one of the limitations of GXT2 was that you couldn't mix it very well with the GWT widget hierarchy. But in GXT3 we updated that to be fully consistent with the GWT 2.4 cell concept and infrastructure. So all of our widgets extend a GWT abstract input cell, and in fact they're interchangeable. So anywhere that you could use a GWT cell widget, you can use a Sencha cell widget as well, a GXT widget, and vice versa. If you want to drop a basic GWT widget in one of our tables or grids, that's fine, you can do that. There is one caveat to that, and that is that it works better if you don't intermix them like this all the way throughout. So if you have your container hierarchy all GXT down to the leaf nodes, or the reverse, if you have your container hierarchy all GWT down to the leaf nodes, and then just put in the widgets of the other type at the lowest level, it'll work best. The reason for that is that the GXT widgets are designed for enterprise applications, and therefore offer a more application-like construction mechanism where each widget passes the resize events down to its child widgets and expects to resize them. So all the Sencha widgets implement on requires resize, or just requires resize. It's an interface in our framework, whereas the GWT widgets don't. So if you mix them, you're going to see layout issues where things aren't resizing properly. I point that out just because last time I was in this audience, there were some of our customers there, and some of them said, aha, that's my problem with resize. So save yourself some trouble if you decide to pick these things up. Okay, I mentioned earlier the flyweight pattern. This was something that GWT introduced with the 2.4 cell concept and infrastructure. And basically, it allows much higher performance rendering because you just attach a little bit of code to each cell, which tells it how to render. So rather than passing big chunks of data to code to one set of code, you pass little chunks of code to your table, and the performance is much better. And we have implemented our widgets the same way, following the GWT lead there. So in general, GXT tries to track GWT very closely. So beginning with version 3, when the GWT compiler changed and added these new features like cells, then we brought it up to speed as well. So here's an example of configuring cell widgets in one of our grids, for example. One other thing that's a little different about GXT is that the click handlers are actually named select handlers. So if you start working with the framework and are looking for on click, you won't find it. You will find on select. Actually, now that we're starting to look more at mobile support, this seems like it's genius because you don't click on mobile, you touch or select. So it's a verb that can be used either way, but I'm not sure why they chose that name originally. Maybe they were genius. All right, let's talk a little bit about layouts. So there's a container hierarchy of GXT containers. You can see here we have the resize container at the top of the blue section, and most of the main containers extend from that. So that's an important concept that you want to get your head wrapped around when you first start with the GXT widgets. We support the standard GWT UiBinder. The vast majority of our widgets can be declared in UiBinder so that you can use XML for your layouts rather than writing Java code for all that. Most GWT developers still prefer UiBinder actually, or do prefer UiBinder to the older way of just doing everything with constructors. Coming soon is going to be support of GSS. So this is the closure style sheet compiler, which has been added to GWT. Closure was a Google language that offered a lot of optimizations for JavaScript and CSS. And what the GWT team at Google has done is merged in as many of those features as they can so that a GWT application can get the benefits of closure optimizations as well. GSS is coming in, I believe, the 2.8 release, which is the next one of GWT, and that will allow you to minify and obfuscate your CSS at a higher level than what's currently possible with GWT. XTemplate is a GXT concept, which is a little bit unusual, but very powerful. It's similar to UiBinder, but allows you to do more. So both of these examples shown here are list views, but they're using a different XTemplate to generate the layout. And these produce safe HTML, which is the GWT class for your cross-site scripting escaped HTML. So anywhere that you can use a safe HTML object in the GWT framework, you can use an XTemplate instead. So let's show you what one of those looks like. It's very simple HTML string replacement, basically. But with a few extra twists, you have the ability to do for loops, and you can also do conditionals in your templating. To declare one, you just need to write an interface that extends XTemplates, and then put an annotation on the method, which actually renders the template. So here we're declaring render template method, takes a person object, and gives us safe HTML using the template.html. And then you create that like you do with most things GWT. In the bottom example, you can see it's also possible to put your code for the template in line right in the annotation, so you don't even have to use a separate file if it's just simple. Custom theming is a new feature it's available now in, I think, 3.1 and following. It's how we did this application that I showed you. Basically, to create a custom theme, let me go ahead and show you one here. Yeah, e-theme here. There's a lot of property, it's very CSS-like, but it's not CSS. So basically, rather than have a huge number of CSS classes that are necessary to style the widgets, the idea was to reduce it to a core set of properties that could be applied across all the widgets. So what we have here at the top section is 5 or 6 of those properties for borders and panel backgrounds and things like that will get applied across the entire widget set. And then there's a details section where if you choose to, you can override for specific widgets, specific attributes as well. So what we did to make the E- application was we just took the Neptune theme, which is the blue one that you saw in the demos, and adjusted some of the properties in order to create this theme file. And what will actually happen when you compile your application is it will take this theme, it will produce the corresponding CSS files that are needed, and it will also produce any custom Java appearance classes that are needed for the more advanced properties. That happens at build time, and it's all integrated with Maven optionally as well. So we're trying to make it easier to get a consistent look and feel across GWT applications, which has been one of the relatively difficult things to do. We have a whole lot of charts. I talked a little bit about those earlier. And then stores and loaders is the last component of GXT that I'll talk about. This is the basic model of how it works in case you decide to start developing with it, is that your widget will be attached to a store. The store is a model object that actually holds all the data, and you filter by way of the store rather than directly on the widget itself. The store is where you also go to load data. The store will call a loader. Those two are bound together, uses a special binding class. And then the loader in turn contacts a proxy for the specific type of data that you want to load. So the 3 main types are, again, the GWT RPC, request factory, and request builder, which is just a vanilla HTTP connection from GWT. So first we'll take a look at the store. This is where you do filtering and sorting, as I mentioned. It also triggers change events. They're called data change events, and they're parameterized with your model type. So you can use these things in your application elsewhere if you want. You could write a listener to get the event bus and listen for a data change event on a specific type of model object, and then couple loosely other parts of your interface to that. They accept any object type, and there's 2 basic types, the list and the tree. So moving on to loaders. These can deal in terms of any POJO, any model type in your application, and they in turn send things to data proxies. So let's look at the proxy. These are just a generic class that are parameterized in terms of an input and an output type. So you create a data proxy that knows how to take a certain type of request object and knows how to return a certain type of result. The naming convention is a little weird because the input types are actually called configs. But once you realize it's just an input type or a request type, it makes a lot more sense. So there's 3 of them that are defined by, or available by default for you, the HTTP, the RPC, and the request factory proxy. But it turns out it's also very easy to create your own. So I just want to show you a quick demo of that. I have a sample project here where I wanted to create a widget that would populate from the Yahoo API that does stock quotes. It's just a simple REST API, which is completely undocumented, but several people have reverse engineered it and posted on Stack Overflow. So I borrowed it. It looks like this. if we actually make a request. Yeah, so here's the raw JSON that comes back from the Yahoo .quote API. And what I want to do is turn that into something a little bit nicer. Let's see if it's actually going to load it today. I think I was actually running in a dev mode instance that I've closed. So sorry about that. But the code, we're more interested in code anyway. This is a data proxy class. So I just created my own quote proxy that extends or implements the data proxy interface from Sencha GXT. I'm using RestyGWT here, which is a nice little framework that lets you use the standard JAX RS annotations to create REST services in your GWT app. So I've just defined the JSON response in terms of this YQL response object. I've just created a bunch of nested classes to make it easy to see the structure of that response. So this is all RestyGWT, these top lines here. And then the bottom line is where we actually implement the load method to go get the data. And this is the only method that's required to implement when you extend the data proxy interface. And once you get past all the automatically typed signatures when you hit Control 1 in Eclipse or whatever, you get down to this, the service.get. We pass it our request object, which is a YQL query, a couple other parameters required by Yahoo interface, and then the callback, from which we'll get back a YQL response. RestyGWT takes care of all the serializing and deserializing the objects, and we implement the on-failure and on-success methods just like with GWT-RPC. So this data proxy I can now use directly in a to bind to a Sencha widget, so I'll just show you the quote for that as well. These 4 lines basically instantiate everything that's necessary. So we have the data proxy, the loader, we create a properties class, which I'll talk about in a minute, and then a store. And all these, the quote proxy I had to write myself by implementing the data proxy interface. The list loader and the list store are all provided as part of GXT, so I don't have to write those. Then I just bind them together and add a handler, and that's it. So it's not too difficult to extend your own, or to use whatever service layer you wish to get data and bind it to Sencha widgets. The last little piece of wiring that I need to talk about is a ValueProvider. So this is essentially metadata. It's just describing your model to the framework. And the way you do that is just using these path annotations, which provide the getter and setter name. And then the ValueProvider is in terms of your model object, and it always outputs a string. Well, it doesn't have to, but it's the most useful way. You bind it together like this. So we have this property access class for a blog post called post properties, which has value providers for username, forum, and date. We just gwt.create it, and then anywhere we need one of those properties, like in a cell, we can make a column config and just invoke our the method that we've created. So that's how we implement the flyweight pattern. And how we can make it possible to, in a performant way, get data out of those model objects and into the HTML. I just did this demo, but I do want to point out that this is a useful element if you're writing GWT applications that collapse all properties. It should be the default in GWT 2.7, but what it does is GWT normally creates one permutation for each browser that has the JavaScript that's optimized for that browser. But when you're first launching Super Dev Mode, it takes a lot of time, like 3 or 4 seconds typically, to create each permutation. So you're better off just creating one permutation that contains the code for all browsers. It won't be as performant, and it's a little bigger, maybe 10 to 20%, but for development it's great because it saves you like over half the time typically. So it should become the default soon, but if you're on an older version of GWT, you might want to put that in your GWT XML and get the performance benefits of that.
Sorry for interrupting.
Yes?
Is it possible to connect the widget to an Oracle table, for example?
Sure. You can connect a widget with any kind of backend data. So is it available via like a REST API or?
Oracle table, for example.
Yeah, so an Oracle, I'm not familiar with Oracle. I worked for Google too long to know anything about Oracle, but what's the actual data interface? Is it a proprietary data protocol or? Okay. I mean, if it's non-proprietary and you can get access to the actual data format, whether it's JSON or something like that, then yes, you should be able to connect it. Just a couple slides here on what's coming in GXT4, which should be out second quarter of this year. We're planning to add support for tablets, so touch events and gestures that will work on tablets. Planning to add a new graphical theme builder as well. We're still working to decide whether that's going to be part of the core framework or an optional product or what, but the idea is to make it a lot easier to style your GWT applications. And then there's going to be a few upgrades to charts, including things like zoom and pan gestures that will be optimized for tablets. The main focus of the release is tablets. So one closing slide here on why you might want to use GXT. This is, of course, assuming that you're already using GWT. That would be a whole nother presentation. But if you need good-looking widgets for your enterprise web app, you know, we have spent several man-years now and have hundreds of thousands of lines of code that are getting pulled in to present these widgets in a cross-platform way, meaning IE, Firefox, Opera, Safari, Chrome, etc. And the team triages issues daily. We find, you know, somebody says, I'm using X version of outdated browser with GXT 2. Whatever, and we go through and we create a patch if necessary in order to keep their application running. We try to track GWT very closely. So GWT is looking at making major changes soon here to the widget class. It was originally written at a time when browsers were much less well-behaved than they are now, if you can believe that. And so there's big changes coming, and we're tracking those, and we'll be updating our widgets with the GWT framework as well. Specifically, the idea of widget may be going away or moving into a separate module in upcoming versions of GWT, which scares me a little bit. I understand the reasons why they want to get closer to the DOM, but I think for a lot of applications, widgets are a useful way to write code, and a lot of enterprises aren't going to want to change overnight. So we're also contributors to GWT. Brandon Donaldson has done a lot to keep the Google plugin for Eclipse running and integrate super dev mode support there. He's a Sencha team member. We've got other projects that are coming along. Several people at Sencha are members of the GWT steering committee, and we've been involved with the changes in the last year around super dev mode especially. So we want to remain active participants and contributors to GWT. Our future is dependent on it, on the GXT team, but we want to help contribute to the ecosystem as well. So one of the benefits you would get from being a GXT customer is that when changes do come along, chances are we've already encountered them, like the super dev mode stuff that happened this year, and help you deal with that in your enterprise. I believe I'm out of time, but I want to thank you very much. I guess that's the last slide, for listening. And does anyone have any questions? Yes?
Yeah, I'm just curious about I'm curious about what versions of the browsers you're supporting, or from which version of Firefox, Chrome, in IE, and so on.
Yeah, right now I believe GXT2 goes. The question is, which? Yeah, GXT2 goes back quite far. I don't know if it's like IE 8 at least. GXT3 I think starts probably at IE 9. The Firefox and Chrome versions I don't know offhand, but quite far back. Yeah, it's actually a disadvantage for some people. There's a lot of code we could remove if we didn't still have to support those older browsers, but a lot of our enterprise customers use it specifically because we do. So, other questions? All right, thank you very much.